Let's continue our discussion of control systems and steady state errors by looking at steady state errors for a specific kind of an input. And in this video, I'm going to talk about a step input. Okay, so we've already looked at the fact that steady state error is given by this equation, and here I have already substituted for the input. Now this is a step input, so the step input is given by a over s in the Laplace domain. So that's going to be your input. Now this s here in the numerator and this s in the denominator cancel each other off, and therefore you can write the steady state error as like this, right? Now, now let's now we've already talked about the type of the system. Now, if we assume that the type of our system is zero, that is, there is no pole at the origin at s equal to zero, then this equation becomes fairly straightforward because there is no zero at the denominator, and it will turn out to be this equation, right? And this value here, 1 plus k times this product, this k and this expression here, can be denoted by a constant value, which is called the position error constant. Okay, and the position error constant the steady state error can be represented in terms of the position error constant like this. Now, on the other hand, if you have a system which has a type which is greater than 0, so type 1, type 2, type 3, and so on, whatever higher than 0, then what happens? What happens is that you have an s in the denominator here, and because of that, when you take the limit and you put s equal to 0, this term becomes very, very high or almost infinite. Therefore, the steady state error becomes 0. So for a step input, if the system is type 0, you have a steady state error, and the steady state error is given by this equation. If you have a system that is bigger than type 0, that is, it's type 1, type 2, type 3, and so on, the steady state error is always going to be 0.